Hi everyone. So in this video, we're going to be starting a new chapter in the textbook, and in a lot of ways, this is really transitioning to the second half of the quarter. So the first half of the quarter is really focused on building up a lot of conceptual understanding about how functions work in general, right? So we talked about domain and range, graphing functions, interpreting the graphs of the functions, transformations, composing functions, inverse functions, and all of that stuff was just sort of general about all functions, right? And so the second part of the quarter is going to be focusing more on specific types of functions. So the first specific type of function we're going to be looking at is what's called a quadratic function. And so we're going to spend a few videos on this. This first video is going to be kind of a basic overview. So I think for most of you, the content in this video, it should be review. Whereas in the next couple of videos, we'll get into some stuff that is a little bit more tricky and potentially stuff you have not seen before. Okay, so what is a quadratic function? So a quadratic function is basically just a function where your highest power of x is x squared. So I'm going to write that kind of formally here. So it's a function of the form f of x is equal to ax squared plus bx plus c. And so here, a, b, and c, kind of like when we write down the equation of a line as, mx plus b, a, b, and c here just represent numbers. So a, b, and c are real numbers. And then we have to add a little restriction here, which is that in order for this to be a quadratic function, this number a cannot be 0. So b and c are allowed to be 0, and I'll show you some examples like that in a second. A is not allowed to be 0 because then you would not have an x squared part, right? If you had 0x squared, well, that means there's no x squared. And so what you'd be left with would be a linear function. It would no longer be quadratic. So what are some examples of what quadratic functions might look like? Well, you could have one like this, f of x is equal to negative 2x squared minus 4x plus 1. That's one where you have a, b, and c, none of them are 0, right? So you have an x squared part, you have an x part, and you have just a number part. But you could also have something like this one, x squared plus 1. So notice that does not have a middle term. It doesn't have any just x term. And so that would mean that b is 0 in that one. You could also have something like h of x is equal to 3x squared minus 15x. So that would be an example of a quadratic function where there's no constant term. There's no just number being added at the end. But notice they all have an x squared part. That's really the defining quality of a quadratic function. Okay, so what does the graph of a quadratic function look like? Well, it's what's called a parabola. So the graph of a quadratic function is called a parabola. So we've seen parabolas in this class, and we know that they kind of look like this, and it could be facing upward like the one that I'm drawing right now. It could also be facing downward. I'm just going to draw this upward facing one as our kind of first example, but we will see at least one example in this video of a parabola that is facing downward as well. So there's a few special points on the graph of the parabola, and these special points are really what we're going to be focusing on in this video. So the first special point is the place where the graph crosses the y-axis. So just like with lines, or actually any function, wherever its graph crosses the y-axis, that is always going to be called the y-intercept. And then, if the y-intercept is where the graph crosses the y-axis, well, then that means that we can give a similar name to the places where the graph crosses the x-axis. So these points are called the x-intercepts. And we didn't talk about x-intercepts for linear functions, but they exist for linear functions as well. So basically, like with the same deal with y-intercepts, every function, if it crosses the x-axis, you call that point the x-intercept. And then one final point that is important to recognize in a parabola or in a quadratic function is this point down here. So the point that's basically, if the parabola is facing upward like this, the point that's all the way at the bottom, or if the parabola is facing the other way, it would be the point all the way at the top. That point is called the vertex. And so this video is basically going to be focused on how do you find these points, these 4 points, and then using those 4 points to sketch the graph. So what we're going to do is we're going to write down on this page kind of a general procedure for finding each of these points, and then we're going to, as we learn each of those procedures, we're going to go and do an example. And then once we're done going through all these different procedures, then we'll do a few more examples just to get some practice and see some of the different kind of issues that can come up and different kind of methods that come up. Okay, so the first thing I want to talk about is finding the y-intercept. Okay, so I'm just going to sketch a quick little sample parabola here. So if this is our parabola, so the y-intercept is this point here, right? That's where the graph crosses the y-axis. So notice that the y-intercept, the y-coordinate is going to vary, right? Because depending on where the graph crosses the y-axis, that point is going to be, maybe it's positive, maybe it's negative. It can be, anywhere along the y-axis. However, the x-coordinate of that point is always going to be 0, right? Like no matter where that point is, if it's on the y-axis, which it is because it's the y-intercept, the x-coordinate is always going to be 0. So I'm going to kind of write that like this. I'll put a question mark for the y-coordinate because that's going to vary, but I'm putting 0 as the x-coordinate because that is always going to be the x-coordinate. So we can use that fact to figure out what the y-intercept is. So the x-coordinate of the y-intercept is always 0. And that goes not just for quadratic functions, that's true for any function. Any function, the x-coordinate of the y-intercept is always 0. So how do you go about then finding the y-intercept? So if you have a function, if you have a formula for your function, and you know the x-coordinate of a particular point, how do you find the y-coordinate of that point in general? So again, question is, if you have a function, you have a formula for that function, you know an x-coordinate, how do you go and find the y-coordinate that goes with that x-coordinate? So you would plug the x-coordinate in, right, and see what you get as your output, and that would tell you the y-coordinate. So to find the y-coordinate, of the y-intercept, we want to plug in x is equal to 0, right? We're going to set x is equal to 0 and see what that gives us as y, or as, f of 0, our output. So let's go and, as I said, as we learn each of these, we're going to look at this specific example so we get to practice them right away. So the first function I want to look at is x squared minus 5x plus 6. So let's start by finding the y-intercept. So as we saw on the last page, how do we find the y-intercept? Well, we just set x equal to 0 and see what that gives us. So we would get 0 squared minus 5 times 0 plus 6. And so that's just going to be 6. And so the y-intercept is a point, right? It's not just a number, it's a specific point on the graph. So we want to actually write down both the x and the y coordinate. So the x coordinate, as we said, is 0, and the y coordinate we just found out is 6. And so that means that the y-intercept is going to be this point right here. Now you might notice that the y-intercept is actually just this number, and that's going to always be true if your quadratic function is written down in this form. So what we'll see in the next video is that there are other ways of writing down the formula for a quadratic function. And so I just personally think it's better to get in the habit of just plugging in 0 to find the y-intercept, because that will work no matter how your function's written down. And it will also work just for any type of function. It's just kind of a good principle to have in mind in general. To find the y-intercept, plug in x is equal to 0. Otherwise, if you try to just memorize that it's this number at the end, if the formula is written down a different way, that might kind of throw you off. Okay, so back to the kind of general things here. So let's now talk about finding the x-intercepts. And we'll see in this video that sometimes the graph has one x-intercept, sometimes it has two. We'll see in a later video, sometimes it actually has none. But let's, for the sake of this picture, I'm going to draw an example that has two x-intercepts. Okay, so let's kind of follow the same line of reasoning that we did in the example above. So in the example above, we said that, okay, the y-intercept is always going to be a place where x is equal to 0, just because of how it lies on the graph. So similarly here, what can we say about the x-intercepts? You know, again, we don't know what the x-coordinates of the x-intercepts are, because that's going to vary depending on the function. But what can we tell for sure? Well, we can tell that the y-coordinate is 0, right? Because if your graph is going through the y-axis, the x-axis, that is going to be exactly when y is equal to 0. So I'm going to label each of these points with a question mark for the x-coordinate, because we don't know what the x-coordinate is, but we do know for sure that the y-coordinate is 0. So by the same kind of reasoning as we said above, so actually let me just write this down, so the y-coordinate of the x-intercepts are always 0. Okay, so how do we then go about finding the x-coordinates? So again, let's think kind of in general. So if you have a formula for a function and you know what the y-coordinate is, so you know the output, how would you then figure out what's the input that goes with that output? So you're given a formula, you're said, you know, the output of this formula is 0. How would you go about finding the input that goes with that output? Well, you would set the function as a whole equal to 0, right? Like if you're trying it, so in this case, we know what x is, right? We know that x is 0. And so we plug in x is equal to 0. And so on the other hand, here we know that y is 0. And so remember, the y coordinate is your output. And so what we're going to do is we're going to set the whole function equal to 0 and solve for x. So to find the x coordinates of the x-intercepts, we're going to set the whole function equal to 0, because that's like setting y equal to 0. And then we have to solve for x. So I really want you to understand this step. I think there's a lot of people who kind of memorize the fact that, oh, you have to factor or use the quadratic formula, but don't really understand where that's coming from. So I just really want you to understand that we'll see that we're going to factor or use the quadratic formula, but the reason that you're doing that has to come back to the fact that you're setting the function equal to 0. If you don't understand that part, then it's going to get a little confusing for you in later sections. Okay, so how do you solve a quadratic equation equal to 0? Well, you're generally going to solve either by factoring or using the quadratic formula. So let me just finish this sentence by saying that. Okay, so the first example we're going to do, the one we already started with, that one's going to be factoring. So maybe let's actually just go and do that now, and then we'll come back and I'll remind you what the quadratic formula is. Okay, so now we're going to find the x-intercepts. So as we said, the x-intercepts, we want to take our whole function and set it equal to 0. So we have 0 is equal to x squared minus 5x plus 6. And so we can factor this right-hand side, right? So how do we factor? Well, basically, you're looking for two things that when you multiply them together, you get x squared minus 5x plus 6. And so to get the x squared, we need x and x. Then we need two numbers to go here and here, that when you multiply them together, you get 6. And then when you add those two numbers up, you have to get negative 5. And if you don't quite get why that is, I'll show you in a second. It's basically just working backwards and seeing how these things multiply together. So what would be two numbers that when you multiply them together, you get 6, and when you add them up, you get 5 or negative 5? Well, negative 2 and negative 3. So the nice thing about factoring is you can always check. So you can check by multiplying this together. And so you'd get x squared minus 3x minus 2x. So that's where the negative 5 comes from, and then plus 6. So we'll do another example a little later in this video where the factoring is a little trickier, but that same idea of guess and check is going to be really useful. Okay, so in general, I'm going to kind of write this off to the side as a fact. So this is what's called the zero product property. And this is something that we've already been using in this class, but I just never really said it explicitly. So the zero product property says that if you have two numbers being multiplied together, so I'm using A and B here to represent two different numbers. And if those two numbers, when you multiply them together, you get 0, then it has to be true that either A is equal to 0 or B is equal to 0. And I want you to just pause and think about like why that makes sense. I want you to really understand that that's true, right? There's no way that you can multiply two numbers together and get 0 unless one of them is 0. Try, you get extra credit if you can come up with two numbers that you multiply together and you get 0 where neither of the numbers is 0. And so what does that tell us here? Well, this is our A and this is our B, right? These are two different numbers, x minus 2 and x minus 3. Each of those is a number. And so that tells us that either x minus 2 is equal to 0 or x minus 3 is equal to 0. And that tells us x is equal to 2 and x is equal to 3. Now, a lot of you, I think, might go straight from here to here. And, that's fine, but I want to make sure you understand where it's coming from. Like you might have just memorized the fact, oh, I just flipped the sign of this number. If that's how you're doing it, you're going to run into trouble when things get a little bit more complicated. So I really want to make sure you understand that, this step is happening. Even if you're not writing it down, that's the reason that these signs flip. It's because you're solving an equation where you're adding something to both sides. Okay, so this tells us now the x coordinates of the x-intercepts. And so our x-intercepts are going to be 2, 0, and 3, 0. So I'm just going to go ahead and put those on our graph, 2, 0, and 3, 0. Okay, so as promised, I just want to quickly write down the quadratic formula so that it's just kind of all in one place. So the quadratic formula, again, is something that you should have learned in a previous class, but I'm sure some of you need a quick reminder. So the quadratic formula is used specifically for solving equations of a particular form. So the quadratic formula is used to solve an equation that looks like this: ax squared plus bx plus c is equal to 0. And it's kind of a shortcut. It's a shortcut that if you have an equation that looks exactly like this, then the solutions to that equation are going to be negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this is a formula that you're going to want to memorize. It's just very useful. It comes up all the time in math. But again, I really want to make sure you remember like why and when you're allowed to use a quadratic formula. So you specifically use the quadratic formula when you have a quadratic equation. So an equation that looks like ax squared plus bx plus c, and it's equal to 0. You can't use it if you have an equation equal to something else. It's only when it's equal to 0. And then, by the way, and we'll see this when we get into an example, what does this plus or minus symbol mean? Well, that means that you actually have two different solutions. One of the solutions is negative b plus the square root of b squared minus 4ac all over 2a. And then the other one is the same thing but minus. And so you want to make sure that you're aware that that's actually two different numbers. And we'll see that a little bit later. And by the way, we'll also learn where the quadratic formula comes from a little bit later as well. And by the way, you could actually use the quadratic formula on this. I would encourage you to try it. You would get the exact same two answers. So you can always use the quadratic formula. It will work for any quadratic equation equal to 0. Personally, I think that factoring is generally easier if you can do it, if it factors, and we'll see an example later that does not factor. But if you can factor, that's generally just going to be the option that will give you less potential for errors. It's very easy to make mistakes with the quadratic formula. Okay, so last kind of point we want to talk about. So we talked about y-intercept, x-intercepts. Last thing we want to talk about is the vertex. Okay, so this one, I'm just going to kind of tell you what the formula is, and then I'm actually going to put on the worksheet a question that will help you understand where this formula comes from. I just think it's a proof that actually isn't that hard, and I think you might get more out of it if you do it yourself rather than watching me do it. So I'm going to put a question again on the worksheet that will show you exactly where this vertex formula comes from. It'll kind of break it down step by step. So basically, the vertex of a quadratic function f of x is equal to ax squared plus bx plus c is going to be, so the x coordinate is going to be negative b over 2a. So basically just taking those numbers b and a and putting them into this formula. And then if you know the x coordinate of a point on a graph, how do you find the y coordinate? Well, you just plug it in, right? And so whatever that x coordinate is, you're going to plug that into your function and find the y coordinate. So again, let me just write down a note here because I really don't like to give formulas without explaining where they come from. So, why is this the formula? Look at the worksheet. The worksheet will show you exactly why this formula is what it is. So let's go and use the formula on this example. So to find the vertex, we want to take our equation. So our function was x squared minus 5x plus 6, just to remind you. And so the vertex, the x coordinate of the vertex is going to be negative b over 2a. And so in this case, b is negative 5, right? B is the number that we're multiplying with x, so that's negative 5. And so we're going to have negative 5 over 2 times, and then what is a? Well, a is just 1, right? Because x squared is not being multiplied with any number other than 1. And so the negatives become positive, and we end up with 5 over 2. And then to find the y coordinate, we just plug that number in. So we're going to do f of 5 over 2. And so that is equal to 5 over 2 squared minus 5 times 5 over 2 plus 6. So just got to do a little bit of fraction work here. So 5 over 2 squared, that's 25 over 4. 5 times, or negative 5 times 5 over 2 is negative 25 over 2. And then we have plus 6. So we can make a common denominator of 4. So that'll be 25 over 4 minus 50 over 4 plus 24 over 4, all of them with a denominator of 4. And if you put all of those together, you'll get negative 1 over 4. So that tells us that the vertex is 5 halves negative 1/4. So now we can go and graph that point. So 5 halves is 2.5, so halfway between 2 and 3, and then, negative 1/4, something like that. And so now we can go and sketch the graph. One other point that might be nice to put down is that, so if you look at where the vertex is, that's going to be like right along the middle of your parabola. And the parabola is symmetric. And so whatever points you have on one side, you're going to have points directly across on the other side. And so what that tells us is that if we look at this point here, we can actually figure out another point just by kind of drawing something symmetric. And so if we have a point there, we should also have a point here. So nice thing about parabolas is you can basically, once you have a a point, you actually have twice as many points because you can always do something directly across as long as you know where the vertex is. Okay, so now, as I said, we're just going to do a few more examples. So definitely feel free, and I recommend that you pause the video and try some of these yourself rather than just watching me do it. Each of these examples is chosen to kind of bring up something a little bit different. So I think it's worth it to try all the different examples, even if you feel like you know how this is going. Each of them will bring up something a little bit different. So the next example I want to look at is g of x is equal to 3x squared plus 11x minus 4. So let's start again by finding the y-intercept. Okay, so to find the y-intercept, we're just going to plug in 0, right? So g of 0 is going to be 3 times 0 squared plus 11 times 0 minus 4. And so the y-coordinate is going to be -4. And so that means our y-intercept is 0, -4. So I'm going to go ahead and plot that. Okay, so now let's find the x-intercepts. Okay, so for the x-intercepts, we want to take our whole function, so 3x squared plus 11x minus 4, and set it equal to 0. So you could definitely use the quadratic formula. As I mentioned, you can always use that. But I wanted to show you how to factor this one because it does factor. And like I said, I think factoring is just a little less likely to cause you to make a mistake. You know, if you look at the quadratic formula, it's kind of complicated. The numbers you're going to be dealing with for this one are going to be kind of big. It's just easy to make mistakes. So how would you go about factoring something like this? Well, again, I think trial and error is really the best way. You know, I'm not really going to give you things to factor that are so complicated that you can't do them with trial and error. So let's think first about what we need to do to get this 3x squared. So to get a 3x squared, we need to have a 3x and an x. Right? If we're going to have whole numbers, that's really the only way to get 3x squared. And then we need to put numbers here and here so that we get -4. And that's where we have a good amount of choice, right? So for -4, there's a lot of possibilities. We could have -2 times +2. We could have +2 times -2. We could have 1 times -4, and we could have -1 times 4. So actually not really that many options. But the thing is that they could be swapped, right? Like the two numbers could go in either place. But really, even though it feels like maybe there's a lot of choices, it doesn't take that long to check whether each of them works. So for example, if we put, let's say, -2 and +2, well, what would we get if we multiply this together? We would get 3x squared plus 6x minus 2x minus 4. And so we see that in the middle, we're not going to get 11x, right? We're going to get 6x minus 2x, which is 4x. And so that rules that out. And that also, by the way, rules out the next one. So if you flip the signs, if I made this plus and this minus, all that's going to do is flip the sign of the middle term. So it would end up being a -4x instead of a +4x, and that's still not good. So we can get rid of that one as well. So next up, we can try a -1 plus 4 or +1 minus 4. Let's do the +1 minus 4 and see how that goes. So this would give us 3x squared minus 12x plus 1x minus 4. And so that would give us a middle term of -11x, right? But we want +11x. And so all that tells us is we just need to flip the signs. So if we make this one minus and this one plus, then when we multiply them together, we'll get 3x squared plus 12x minus 1x minus 4. And so that will give us what we're looking for. So that is the correct factorization. There are methods for doing this. You might have learned like a diamond method. There's something called the AC method. I just think that rather than have to like memorize all these different methods and kind of get confused between them, just have like a procedure that doesn't really involve memorization, right? So like this, you don't have to really memorize anything. It's just understanding how multiplication works. Okay, so like we saw earlier, if we have two things multiplied together equaling 0, that means that either 3x minus 1 is equal to 0 or x plus 4 is equal to 0. And so this one would give us, if we add 1 to both sides, we'd have 3x is equal to 1, and then we'd get x is equal to 1/3. Here we'd get x is equal to -4. And so that tells us that our x-intercepts are 1/3, 0, and 4, or -4, 0. Okay, so let's put those points on here. So 1/3, 0 is going to look something like this, and -4, 0 is going to be here. And so, maybe I'll move that a little more to the left. This might look weird for now. You know, this might not seem like it looks like a parabola. It looks like it's going to be like crooked, but we don't know where the vertex is yet, right? So depending where the vertex is, that will help us actually see what this picture looks like. So let's find the vertex. So the vertex, so for the vertex, we're going to find the x coordinate by doing -b over 2a. So in this case, our b was 11, so we have a -11 over, and our a was 3, so we have 2 times 3. So we get -11 over 6. And so to find the y coordinate, we just want to plug that number in. So this is going to be some kind of slightly annoying, probably seeming algebra here, or arithmetic. But we're just going to plug in -11 over 6 into the function. And by the way, I do expect you to be able to write your answer as a fraction. So I don't care if you use a calculator. I mean, I would love if you could do it by hand. I don't care if you use a calculator, but your calculator has to give your answer as a fraction. I'm not going to accept decimal answers on these types of questions unless I'm asking you to round. So here we get 121 over 6. Here we'd get -121 over 6. And actually, sorry, I messed up. We had 36 in the denominator here from squaring it. And then we have -4. And so if you make a common denominator, I did this ahead of time, so I'll just multiply these together. And then this one, if you make a common denominator, comes out to be 363 over, or sorry, I got confused. It comes out to be 726 over 36, my bad. And so just multiplying that middle fraction by 6 over 6, and then this last fraction, we have to multiply it by 36 over 36. So that comes out to be 144 over 36. And so if you add all these numbers together, you get -507 over 36. Not a super friendly seeming number. But so, like I said, I want you to be able to write this as a fraction, but we do also want to be able to get a decimal approximation so we can actually graph it. There's a value to both things. The value to the fraction is that it's an exact number. It tells you exactly what that value is. And the value of the decimal approximation is that it gives you an idea of like where to put that point. So this is the exact point. If you type these numbers into a calculator, you'll get approximately -1.8 and -14.1. So let's go ahead and plot this point. So -1.8 and -14.1. So that's going to be all the way down like here. And so now maybe you can start to see how this could be a parabola. So it's going to be a very like tall parabola, and we'll talk a little bit more about this in a future video, but that's because of this 3. So basically there's been a vertical stretch that has caused this parabola to have kind of a taller shape. And so it's going to be a little harder to get exactly where it is, but there should be another point that's symmetric with this point. So I'm just going to kind of estimate where that point should be, but probably not going to do a perfect job. So I think it's going to be something like this. And so we get a parabola that looks like this. Okay, we're going to do 2 more examples. So next example we're going to look at is going to be h of x is equal to -x squared plus 5x minus 1. So again, let's start by finding the y-intercept. So the y-intercept, we're just going to plug in 0 for x. And we get -1, and so that tells us our y-intercept is the point 0, -1. So here is our y-intercept. Okay, so moving on to the x-intercepts. So we want to set our whole function equal to 0. So we have -x squared plus 5x minus 1 is equal to 0. So one thing that I think can be really helpful, especially if you're trying to figure out whether you can factor, is once you have your function set equal to 0, you can divide both sides by any number you want, and it's not going to change the fact that it's equal to 0. So I'm going to divide both sides of this by -1. And the reason I'm going to do that is because that will make our first term, the x squared term, positive, and it'll just make it easier to see whether we can factor or not. So we're going to end up with x squared minus 5x plus 1 is equal to 0. Now, I just want to point out here, this is an important thing to realize, is that this does not mean that the function, I guess our function is called h of x, this does not mean that h of x can also be written as x squared minus 5x plus 1. This is really important. The only reason that we were able to just kind of get rid of the negative sign is because our function was equal to 0. And if you divide 0 by a number, it doesn't change that number. So similarly, if you're like, let's say that your function was like 2x squared and 10x minus 2, if everything was divisible by 2, we could divide both sides by 2. But that changes, it's not like that gives you the same function. It's just that when you're solving the equation equal to 0, you can do that. So it's really important that later on, when we're finding the vertex, we have to go back to our original function, because this is not our function with the negative sign gone. Sorry, my screen got frozen. This is not our function. This is just an equation that we were able to simplify because it was equal to 0. Okay, so how can we go from here? Well, we could try to factor, but it's not going to work, right? Because there's no numbers that we could put here and here. Like the only choice would be -1 or +1, and none of those is going to give us a -5x. And so that tells us that we want to go and use the quadratic formula. So I'm going to write down the quadratic formula again. (b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And so by the way, when you're doing this quadratic formula, you would actually get the same answer whether you use this for your a, b, and c or whether you use this. Even though they're different functions, they have the same solutions when they're set equal to 0. Not the same exact function, same solutions to this equation. So if you really wanted to, you could go back and use your original equation. It just really doesn't matter. I'm going to use the simplified version or the version without the negative sign, because I just think there's fewer negative signs in it. It'll just be a little easier to work with. So what is our b here? B is -5. So we're going to have -5 plus or minus the square root of -5 squared. So that's our b again, minus 4 times a is 1 times c is also 1. And this whole thing is going to be divided by 2 times 1. Okay, so now we can simplify this. We're going to have 5 plus or minus the square root of 25 minus 4, all divided by 2. And so that simplifies further to 5 plus or minus the square root of 21 divided by 2. So those are our solutions. Those are two different numbers. And in general, you want to look for whether you can simplify this. So if you have a square root where it can be broken down, we've seen some examples of that in this class already. If the square root can be broken down, do that, because that might enable you to simplify something. Like for example, if you had a 2 here and this was also an even number like 6, well then you could do some simplification with the 2. But in this case, 21 there's no perfect square that goes into 21. So that's as far as it can be simplified. So now if we wanted to write down what our x-intercepts are, this is where you have to remember that this thing here is actually two different numbers, right? And so our x-intercepts, one of them is going to be 5 plus the square root of 21 over 2, comma 0. And the other one is going to be 5 minus the square root of 21 over 2, 0. So just like the previous example we did, in order to actually graph this, we need to get a decimal approximation. So these are the exact answers. So on the homework, you'll see there's some questions that ask you for exact form with the quadratic formula. That's what that means. That means you want to leave it in its kind of square root form. Because as soon as you go and type this into a calculator, it's going to give you an approximation. So if you type these numbers into a calculator, what you'll find is that the first one is going to be approximately equal to 4.8. And the second one is going to be approximately equal to 0.2, 0. So this would be approximate. So like I said on the last one, there's a valuable, both of these forms are valuable. The approximation is good for graphing. Exact form is good because, well, it's the exact true right answer. So we can go ahead and graph these points. We have 4.8, so that's somewhere around here. And then 0.21 is going to be somewhere like this. Okay, so that is our x-intercepts. Now we're ready to find the vertex. So the x-coordinate of the vertex is going to be equal to negative b over 2a. So this is where we want to go back to the original function. So the original function is here. So in the original function, b was equal to 5. So we're going to do negative 5. And then in the original function, a was equal to negative 1. And so we're going to do 2 times negative 1. And, to be honest, you would actually get the right answer for the x-coordinate if you used this kind of simplified version that we had here, but you would get the wrong answer when you go to find the y-coordinate. So, and I think just for consistency's sake, I just want to kind of make a distinction between, again, the function and the equation. When you're solving an equation equal to 0, you can do kind of simplifications to your function. When you're using the function itself, you can't like just randomly divide by -1. So I always like to, when you get back to things like the vertex, go back to the original function. Make sure that you understand that what you're using is the function itself. So we're going to get negative 5 over negative 2, and so that simplifies to positive 5 over 2. And so to find the y-coordinate, we're just going to plug that value into our function. So our function again was negative x squared, so we're going to have negative 5 halves squared plus 5x, so plus 5 times 5 halves, and then we had minus 1. And so that's going to give us negative 25 over 4 plus 25 over 2 minus 1. We can make a common denominator of 4. And so that's going to be negative 25 over 4 plus 50 over 4, kind of similar to an earlier example we did. And then last one, minus 4 over 4. So altogether, this is going to be, let's see, negative 25 plus 50 is 25 minus 4, so that's going to be 21 over 4. And so that tells us that our vertex is the point 5 halves, 21 over 4. And so 5 halves, by the way, these we can actually just write in their decimal form. So 5 halves we saw already, that's 2.5. If you do 21 over 4, that's going to be 5.25. So that gives us an idea of where to actually graph those things. Okay, so we have 2.5 and then we have 5.25. So that's going to be like this. And so again, we can use symmetry to find another point. So there's another point here, and then we can sketch our graph. So another thing you might notice is that, this graph is facing upside down rather than right side up. And so that's because of this negative sign. And we'll talk again more about that in a future video about like why that is. But for now, just know that if you have a negative sign in front of your function, it's going to give you a downward facing parabola. However, you don't actually really have to know that. If you know how to find the y and x-intercepts and the vertex, you can trust that that will give you the right shape, regardless of if you're aware of whether it'll be facing upward or downward. Okay, one last example. So let's do the function now. So this is going to be 2x squared minus 4x plus 2. So we can start by finding the y-intercept. So the y-intercept of this is going to be k of 0. So that's going to be 2 times 0 squared minus 4 times 0 plus 2. So we get 2, and so that means that the y-intercept is the point 0, 2. And so now to find the x-intercepts, we want to take the whole function and set it equal to 0. So that's 2x squared minus 4x plus 2 is equal to 0. And so as with the last one, before you try to factor this, see if there's something you can divide both sides by that will make it easier to factor. So in this case, we can divide both sides by 2. And so that would give us x squared minus 2x plus 1 is equal to 0. And it's just always easier to factor something if the leading coefficient, if the number on the x squared is 1, right? It's harder to factor it if it's a number like 2. Again, I'm just going to write this down so that you are sure you understand this. This does not mean that our function can also be written as x squared minus 2x plus 1, right? It's a different function. What is true is that solving this equation is equivalent to solving this equation. These two equations have the same solutions. It doesn't mean that our original function is the same as this left-hand side that we have. Okay, so now we can factor this. So how does this one factor? Well, it factors as x minus 1 times x minus 1. And another way of writing that would be x minus 1 squared. And so in this case, we only get one solution, right? We have x minus 1 is equal to 0, and that tells us x is equal to 1. So we get the same answer either way. And so this tells us that we have only one x-intercept, and it's the point 1, 0. And so we'll see what that looks like, but just so you know, it is possible for the graph to only have one x-intercept. Okay, last thing is the vertex. So to find the x-coordinate, we do negative b over 2a. So in that case, let's go back to our original function. That is negative 4. So b is negative 4. So we have negative 4 over 2 times, and so what is a? A is 2. So we have 2 times 2. And so this simplifies to negative 4 over 4. And so that's going to end up being positive 1. And so to find the y-coordinate, we just plug that number in. This time we have a nice simple number to plug in. So when we plug in 1, we're going to get, so we have 2 times 1 squared minus 4 times 1. Do I have the right function? Yeah, plus 2. And so this is going to be 2 minus 4 plus 2. And so that is equal to 0. And this shouldn't be too surprising. So let me just write this down. Our vertex is the point 1, 0. Why isn't this surprising? Well, we already figured out earlier that the x-intercept of the graph is 1, 0. And so as soon as we knew that the x-coordinate of the vertex was 1, well, we already should have kind of known that the y-coordinate was going to be 0 because that's what we figured out earlier. And so what that means is that the vertex and the x-intercept are actually the same point. And so let's put in that kind of symmetric point. We'll have another point here, and now we can sketch the graph. And what we see is that the reason the graph has only one x-intercept is because it's actually, the vertex is the place where the graph is touching the x-axis. And so we only end up with one x-intercept. All right, so that is it for this video. Please take a look at the worksheet. I do bring up a couple of things on the worksheet that didn't come up in this video. I just, I didn't want this video to go on forever. So there's a couple of questions about maxima, and minima that you should take a look at, as well as an application problem. If you understand how to do everything in this video, you should be fine to do the application problem, but I definitely think it's worth doing that practice. All right, I'll see you all in our next video.